Okay, moving right along in chapter 13. Again, we're moving toward graphing the sine curve and cosine curve, and before we do that, we're establishing the fact that both of them are periodic. So this section is about periodicity and symmetry. So it says a function is periodic if for some positive constant p, f of x plus p equals f of x. So that means the same y value will be repeated after some period of time or some period along the x-axis. So for every x in the domain. So we'll put in an x value, we'll get a y value. If we put in an x value and the period occurs, you'll get the same y value. Again, we'll explain that as probably in the next section in 13.4 when we graph the sine and cosine curve, it'll make a little bit more sense. Periodic functions are repetitive, obviously, with the word periodic. It happens over and over after a certain period, so they're repetitive. And the repeating portion of the graph is called a cycle. So once you see the graph repeat itself, that's one cycle. And then you look at the length of that cycle, and that is called the period of the cycle. So we'll look and see when it starts to repeat itself, that's one cycle, and then we'll see how long that cycle is, and that will be in terms of the horizontal axis or the x-axis, and that is called the period. Recall that the circumference of a unit circle is 2 pi, and why is that? Because the radius is equal to 1, so the circumference of a unit circle is 2 pi. Therefore, s plus 2 pi is associated with the same point xy on the unit circle. So if we look at the unit circle, right, so here it is over here. We have the unit circle. This has a radius of 1. And let's say this is, let's just do pi over 4. So this is pi over 4, which is a 45-degree angle, right? Well, at pi over 4, that ordered pair is 1 over root 2, 1 over root 2, right? It's a 45, 45, 90-degree triangle. So this is 1, 1, root 2. So this ordered pair is in a unit circle, we're going to make that radius equal to 1 length. So maybe that's confusing to some of you as well, sorry. So the radius is equal to a unit of 1, which remember then we had to make this 1 over root 2 and 1 over root 2. So this ordered pair is 1 over root 2, 1 over root 2. Well, if I went around the circle one time, that's 2 pi units, but I went back to pi over 4. So I did pi over 4 plus 2 pi units. So I'm up here at pi over 4, then I go around one time. Where am I going to end? I'm going to end at that exact same position with the exact same y values. So whatever sine of pi over 4 equaled, which was 1 over root 2, sine of pi over 4 plus 2 pi, one lap around, or one revolution around the circle, would also give us the same answer. So that's what this says here. In other words, this is telling us that sine and cosine are both periodic, right? If we were at pi over 2, let's get a different color here. If we were at pi over 2, well, we get a certain value, right? This is 0, 1 at pi over 2. So what is sine at pi over 2? Sine at pi over 2 is equal to 1 because it's equal to the y value. Well, if I was at pi over 2 and I did one entire circle again, so sine of pi over 2 plus 2 pi would also give us a value of 1 because I did one complete revolution around and I ended up on the same terminal side. So it still has a value of 1. Cosine would be the same idea. If we did cosine of pi over 2, we would get an answer of 0. Cosine of pi over 2 plus 2 pi, if we went one revolution in addition to the pi over 2, we're still going to end up here at this terminal side, so it's still going to have a value of 0. So those values start to repeat themselves after one revolution. We're going around again and around again. So it says, therefore, what is the period of the sine and cosine curve? In other words, when do the y values start to repeat themselves, or when do those ordered pairs start to repeat themselves, not necessarily the y values. Well, yeah, it is actually the y values if you were going to graph it. Then that would be 2 pi units, right? After we go one revolution around, all those values start to repeat themselves. And then 2 revolutions around, they repeat themselves, repeat themselves, repeat themselves. Okay, now obviously we don't only have functions, there are functions beyond sine and cosine that are periodic. We could have any type of thing and make it periodic if we want to. So it says this part of a graph of a function f has a period of 3 units. So that means it repeats itself every 3 units. So in other words, remember the word cycle and period up there. This is one cycle, and it has a period of 3 units. So it says graph the function between -3 and 6. So we have to repeat this function from 3 to 6 and from -3 to 0. So I'm just going to eyeball some what I think are key points. So this looks kind of like an exponential growth right here, growing. So I'd say after 1 unit, I'm going to cross 1, and up here, about 1.5 units, I'm going to go up to 3. So this is 1.5 units away. And then I'm going to curve down. So right after this number, I'm going to curve down and end here. So now it's important that I get that shape like this, and then it goes like that. So this blue part needs to be identical to the original black over the period of 3 units right here. So this would be another cycle right here. I have to repeat that cycle to the left. So again, I'm starting down here. After about 1 unit, I'm crossing at 1. About 1.5, I get to my maximum. I come down after 2. I get down around here and end here. So I have to curve up like an exponential, come out, flatten it out, and you're just doing your best to try to make it look like this right here. So here are 3 cycles of this function that's periodic, meaning it repeats itself every 3 units if it has a period of 3 units. Okay, so now we're getting to the symmetry part. Periodic functions sometimes involve symmetry. Under the following rules, all functions, not just periodic ones, can be classified as either odd or even. A function does not have to be odd or even. You could also say it is neither. So it is neither odd nor even, but it's still symmetric. Okay, so how do you know if something's odd or even? Well, you can look at it visually to know, and you can also look at it algebraically to determine if something is odd or even. The algebraic way, so if something is an odd function, that means when you put in the opposite of x, so if I put in -x to x in the original function, I would get the opposite y. So if I started with f of 2, right, so f of 2 equals 3. And this says if I put in the opposite of 2, which is -2, I would get the opposite of y, which is -3. So this means it is symmetric with respect to the origin. So if I started with the original point xy, this says if I put in the opposite of x, I would get the opposite of y. If I put in the opposite of x, I get the opposite of y. So 2, 3, point 2, comma 3 turned into point -2, -3. That's an odd function, which means it has symmetry with respect to the origin. So notice what happens. We went to the right 2, up 3. That was the original point. Well, left 2, down 3. So it rotates. That's also known as rotational symmetry. Okay, it rotates 180 degrees about the origin. That's what origin symmetry with respect to the origin is. It's also called rotational symmetry. That means if you turn your paper upside down, you should see the exact picture as if you held it just the way it was originally. Sometimes that's a little harder to see than when you have symmetry that's an even function. So when you have an even function, that means if I had f of 2 equals 3, well, when I put in the opposite of x, I would still get the exact same y. My y value doesn't change. So if I put in the opposite of x, I still get the exact same y value. Okay, well, let's think about what that looks like. If I have 2, 3 as my original point, when I put in the opposite of x, I still get 3. So where is my symmetry? Well, my line of symmetry then is the y-axis. So it's symmetric with respect to the y-axis. So this one has rotational symmetry. This one has line symmetry where you fold it in half. This is like a mirror, or it's like a mirror, and you would see the same picture on the right and left side of the y-axis. Okay, so go ahead and copy number 1 through 3 on the oral exercises on page 621 in the space below and answer the questions and see how you do. So pause and try that now. Okay, so here are the 3 sketches. Mine are very, very sketchy, not super accurate. But here, notice these points. So the points of where they intersect is important. If you flip this paper upside down, you would see the exact same picture. This would be up here, this would be down here. So this has rotational symmetry. So in other words, it is an odd function. So this is an odd function. For the second one, notice it goes intersect at -1 and +2. So the center would be here. So the line of symmetry is not the y-axis, and you don't flip it. You don't have anything down here. So it's neither odd nor even. So this is neither odd nor even. And for the third one, notice this, the line of symmetry is right through here. You're seeing the exact same picture on each side of the y-axis. So this is an even function. Now what is the period of each of these? So here for this period you should have seen that this was a 4, so my period was equal to 4 for this first one. For the second one, when does this trapezoid looking figure tend to repeat itself? So that was every 3 units. And for number 3, when does this little semicircle repeat itself? So here you can see it's every 2 units. Okay, let's look on the back. So now you're going to practice sketching, and you're going to practice sketching. So here's the picture. Make an even function that's reflective over the y-axis, and then make an odd function that's going to be rotational. So you're going to have to put it so when you turn your paper upside down, you see the same picture. Or remember, even function takes the original ordered pair and makes it this. Odd function takes the original ordered pair, of x, y, and makes them both switch. So x, y switches to the opposite of x, which results in the opposite of y. So there you have it. So you might need ordered pairs if that helps you, if you can't see it very well. For those of you that like art, you're just going to probably be able to sketch it right away because you're going to see that symmetry. So I'm going to pause, go ahead and try it on your own, and then you can compare your pictures with me in a minute. Okay, I'm going to try to finish this in 2 minutes. So go ahead and pause and look at these graphs to see if they compare to yours. See if you have similar ones. So I have my even row, my odd row. See how you did. Okay, lastly, you should know how to find out if a function is odd or even algebraically. That means we're going to have to put in the opposite of x, see what happens as a result, and then decide, did we get the opposite of y, did we get the same y, or did we get neither? Meaning the y didn't turn to its opposite or it remained the same. And I'll show you what I mean by that. So here I put in the opposite of x, so I put in a -x. So this turns into a -2x cubed, and negative times negative turns into a positive 3x. So in other words, if I factored out my negative, here's my original y, but I get the opposite of that. So therefore, what does the opposite mean? It means this is an odd function. So go ahead and try all of these and see if you get the opposite or the same or neither. So pause and try the algebra on your own. Number 5, you should have gotten to be an even function. Number 6 was neither. Number 7 was even. Number 8 was odd. And number 9 was neither. So look at these neithers. Here this was a positive 4x cubed and negative 2x squared. Well, it became a negative negative. So it didn't change to opposite signs, nor did it stay the same, which is why it's neither. Here, this one, people tend not to see the odd. If we factor out a -1, then this x becomes positive. So it's the opposite of the original that we had. So it's an odd function here. For number 9, again, this stayed the same sign, but your negative 2x cubed changed to a positive, but the other stayed the same, so it's neither odd nor even. It didn't flip to its opposite. It didn't stay the same. You can graph them too on your calculator if you want to see visually if it's odd or even, and good luck. Let me know.